In this part of lecture, I will be discussing about acetylcholine and its analogs. And before going to looking at analogs of the acetylcholine, we will discuss how the acetylcholine is being synthesized, right, in the neurons at neuronal level. This is the presynaptic nerve and this is the postsynaptic nerve, right? On the postsynaptic nerve, so whatever the space between present two synapses, two neurons, two neuronal junctions is called as synapse, and the neuron which is present before the synapse is called as presynaptic nerve. The neuron which is present after the synapse is called as postsynaptic nerve. The space present between the two neurons is called as synaptic cleft or synapse. Now we will look how the acetylcholine is being synthesized. Normally, when the glucose enters into the glycolysis, it gives the pyruvates. When pyruvates enters into the PDH, the end product of the PDH would be acetyl-CoA, right? So whatever the acetyl-CoA would be generated from the particular cell organelle. The cell organelle is called as mitochondria. It gives the group called acetyl group, and this acetyl group would get merged with the choline groups with the help of enzyme called catechol-amine transferase. This catechol-amine transferase, which forms the ester bond between acetyl group and as well as choline group, right? So whatever the acetyl group, choline group get merged with the ester bond and forms the product called acetylcholine. This synthesized acetylcholine will be stored into a particular vesicles is called as storage vesicles of acetylcholine in the neurons, right? So whenever the acetylcholine concentration is required in the synapse or to bring the particular action, whatever the action potential will be generated in the neurons and it is propagated towards the periphery and it activates a particular channels is called as voltage gated calcium channels or voltage sensitive calcium channels, right? So whenever the voltage gated calcium channels, voltage sensitive calcium channels gets activated, whatever the calcium which is present outside the cell well enters into the neurons, presynaptic neurons. When the calcium enters into the presynaptic nerve, whatever the storage vesicles which is made up of protein, right, that will get contracted. After contraction of the storage vesicles, whatever the acetylcholine which is it has, whatever the acetylcholine stored in it will be splitted into synapse, and this acetylcholine will be acting onto the particular receptors, that cholinergic receptors, that is M receptors, muscarinic receptors and nicotinic receptors. And nicotinic receptor is of two types, where the nicotinic neuronal subtype which is present in the ganglions, right, all ganglions, and nicotinic muscular receptors, which are present at the neuromuscular junction, where the nerve fibers which ends attached to the muscles, right, for the contraction, right, that is called as neuromuscular junction, right? At the neuromuscular junction, thus nicotinic muscular subtype receptors are present, right? And this acetylcholine will be acting on muscarinic receptor. It is also acting on nicotinic subtype receptors. Now look at how the acetylcholine is being metabolized here. This acetylcholine, if you look at the structure of the acetylcholine here, right, so it is made up of acetyl group and which is connected with the choline with the help of ester bond, and it is getting metabolized a particular series of enzymes called esterases, that is acetylcholine esterases, right? Acetylcholine esterases. If we look at the structure of the acetylcholine esterases, it has two sides and it looks like this, and it is having two sides. One is anionic site and another one is ester site. right? Anionic site as well as ester site here. See, choline has a particular group, right? This choline has a particular group which is containing the quaternary ammonium onium ion, which is possessing the charge called positive charge. This positively charged choline will be held by the anionic site. So it holds, the anionic site holds the choline group which is positively charged quaternary ammonium, right? Now the ester site will break down the particular ester bond which is present between the acetyl and choline, and whatever the choline which is present here will be broken down, and this choline will be reuptaken back into the presynaptic nerve, and this process is called as reuptake process. And this is the rate limiting step. This is the rate limiting step of this synthesis of the acetylcholine. In any particular reaction, any step which is taking more time to get finished, and that particular step of that reaction is called as rate limiting step of that reaction, right? And here, now look at how the acetyl or cholinergic drugs are acting here, right? How the cholinergic drugs are acting here. Any drug which is acting by inhibiting the acetylcholine esterases, and these type of drugs are called as indirect cholinergics. Indirect cholinergics. And any drug which is acting on muscarinic receptors and nicotinic receptors directly. So here the inhibition of the acetylcholine esterases, so it is directly inhibiting the metabolizing of acetylcholine, hence the concentration of the acetylcholine will increase, right? That is why these type of drugs are called as indirect cholinergics. And here directly acting onto the muscarinic receptors and as well as nicotinic receptors, now these type of drugs are called as direct cholinergics, right? So here if you see the drugs which is directly acting or directly blocking the storage vesicles of the acetylcholine is vesamicol, right? This is called as vesamicol. And the drug which is directly blocking the rate limiting step of the choline reuptake process will be hemicolinum, will be blocked by the hemicolinum, right? And it is structurally look like choline, and this hemicolinum vesamicol are used experimentation purpose, not used clinically, right? And a drug, a toxin directly blocking the release of the acetylcholine, right? Blocking the directly release of the acetylcholine, the toxin is called as botulinum toxin, right? That botulinum toxin is particularly used in case of in the migraine. In migraine, it is having a mechanism there. It is decreasing the calcitonin gene related peptide concentration, right? It is decreasing the calcitonin gene related peptide concentration, right? And it is also used in cosmetology, hemifacial spasms. So where the acetylcholine is excessively released and causes contraction of the muscles or face, right? In condition, particularly here, hemifacial spasm. So in this condition, this botulinum toxin is used, and in particular condition called achalasia cardia. In achalasia cardia, where suppose this is the GIT, where it is stomach, and the particular this part is called as cardiac sphincter. This cardiac sphincter will get aggravatively contracted, right? This aggravatively contracted condition is called as achalasia cardia, where the whatever the ingested food will not reaches to the stomach. Now this condition is called as achalasia cardia. So in this particular condition, this botulinum toxin is used for this treatment, right? And there is a one particular drug, that is an antibiotic, which is class of antibiotic, that is aminoglycosides. This aminoglycosides will be blocking the voltage gated calcium channels, thereby no acetylcholine will be released into the synapse due to stoppage of calcium entry into the presynaptic nerve. That causes no release of the acetylcholine. Hence, acetylcholine is very important in case of contraction of the muscles. So that is why aminoglycosides is not facilitating to release the acetylcholine, rather it is stopping the acetylcholine release. Hence this aminoglycoside produces the side effect, it is called muscle toxicity. Right, it produces the muscle toxicity. And let's move to the uses of the acetylcholine here. Now I am taking the acetylcholine. This acetylcholine is not used clinically. The reason being why it is not used clinically here. Acetylcholine, when it is given through the bloodstream, there are a particular series of the enzymes called esterases. So these enzymes are present in the plasma. Hence these enzymes called as plasma esterases. These plasma esterases known as true choline esterase. Another one is pseudocholine esterase. So these particular enzymes will be facilitate the metabolism of the acetylcholine. Hence this metabolism of the acetylcholine will happen within fraction of seconds. Hence acetylcholine is not used clinically, right? So what I'm making here, I'm taking acetylcholine, and after taking the acetylcholine, I make that type of acetylcholine which is resistant towards the metabolism towards plasma esterases. So I'm taking the acetylcholine here. Now what I'm making here, I'm making the beta methylation. So I'm making the beta methylation here. So before going to the beta methylation of the acetylcholine, let's look at a structure of the acetylcholine here. The structure of the acetylcholine here, it is this is the acetyl group where it is attached to the choline here. Now this structure is acetylcholine. Now, so coming to the numbering, it is the alpha carbon where it is more priority group. Here it is more priority group. Adjacent to the this alpha carbon is called as beta. Hence the methylation happens at beta position. Now see the which particular drug comes here. Now making methylation at beta position will get a drug called methacholine. It is beta methacholine. Now beta methylated acetylcholine is called as beta methacholine. Now see the effect on the muscarinic receptor. The effect on the muscarinic receptor here. So making the beta methylation here, right? Beta methylation due to the presence of the acetyl group. Now it is having affinity towards more towards the M2 receptors rather M1 and M3 receptors, right? Now what I'm making, it is somewhat resistant towards the, right, towards the plasma esterases. So I'm taking acetylcholine here, right? I'm taking the acetylcholine and I'm replacing the acetyl group with the carbamyl group, right? This is called carbamyl group. This is called carbamyl group, where this ester bond connected to the choline. Now this particular drug is called as carbachol. Now this drug is called as carbachol. Now see the effect on the muscarinic receptor. Due to the presence of the carbamyl group, it is having more affinity towards the M1 receptors and M3 receptors rather M2 receptors. Right, now this is more resistant towards the, right, more resistant, somewhat more resistant towards the, right, plasma esterases compared to the methacholine, right? Now what I'm doing here, I'm taking the acetylcholine, right, or I'm taking the methacholine, and in the methacholine, so acetyl group will be replaced with the carbamyl group. Now acetyl group replaced with the carbamyl group where the beta position containing methylation, right? So now this drug, right, beta methylated carbamyl group attached this choline is called as bethanicol. Now this bethanicol, due to the presence of the carbamyl group, it is having a more affinity towards the M1 receptors and M3 receptors rather M2 receptor, and it is more resistant towards the plasma esterases compared to all these, right, structures. Now look at the uses of these drugs. Now I am noting down here drugs again, bethanicol, and it is having a activity towards M1 receptors, M3 receptors rather M2 receptors, and carbachol, it is also having M1 receptors, activity towards M3 receptors rather M2 receptors. Methacholine, it is having a more activity towards the M2 receptors rather M3 receptors, right, sorry, M1 receptors, M3 and M1 receptors, right? Now if you see the uses of these drugs, I'm talking about the methacholine now, right? Any drug which is used to diagnose a particular disease, that drug should be shorter acting and faster reperfused drug, right? So that drug should be shorter acting, right? Drug should be shorter acting. Hence this methacholine is shorter acting towards M3 receptors, right? Hence this methacholine is used. This methacholine is used to diagnose a particular disease called asthma. So M3 receptors present in the bronchus muscles, and it is causing bit contraction of the bronchus muscles. Hence this methacholine used for the diagnosing of the asthma. The test which is carried out here, it is called as bronchial challenge test, right? Right, this is about the methacholine. This is the use of the methacholine here. Bethanicol, normally acetylcholine will be utilized, right? Normally the action of the acetylcholine is contracting the muscles, right? Contracting the muscles. Hence bethanicol, wherever it is required to for contractions, in the particular contractions, right? If you see the normally the physiology of the urine storage, right? Suppose this is the bladder of the urinary bladder. This urinary bladder is possessing a particular muscles. That particular muscles is called as detrusor muscles, right? This detrusor muscles, whatever the urine is getting in or filled into the bladder, due to filling of the bladder, for more accommodation it will be stretching, right? It will be stretching for more accommodation, right? So whatever, whenever the detrusor muscle is being stretching, that stretching in the detrusor muscles itself, it is having a stretch receptors. These stretch receptors will send signals to the brain, and that will gives a reminder to us for passing the urine. But in diseased condition, where it is not having a there is not having activity of the stretch receptors, whatever the urine which is filling inside the urinary bladder, which is keep filling, urine is keep retaining, right? In this condition, urinary bladder is not reacting for contraction, right? Not reacting for contraction. Now this particular condition, it could be treated with the bethanechol. Now this condition will be, it is called as, this condition is called as bladder atony. This condition is called as bladder atony, where the bladder is not contraction, that is absence. A means absence of the contraction is called as bladder atony. So in the condition where we want to diagnose or we want to perform surgery in the GIT muscles, what we have to do, we have to remove all the food particles from the GIT. So for that we have to increase the motility for evacuating all the food particles from the intestinal muscles, right? From the intestine, right? So what we have to do there, we have to increase the motility, thereby whatever the food particles which are present in us will be removed out, so we can perform surgery easily, right? Procedural surgery easily. So for that, in that condition, to activate the motility of the GI muscles, the particular drug bethanechol could be used for this condition. Now the condition here, it is called as gastroparesis. Right, this is called as gastroparesis, where the ileus is supposed to close and get opened whenever it is required, but this ileus, right, ileus will be paralyzed, right? Ileus gets paralyzed. In that condition, we need to improve its contractions and relaxations. So in this condition, this bethanechol is used, right? This condition is called as paralytic ileus. So this is about the acetyl choline, its synthesis and its analogs and the uses of these analogs, right? If you like this information, hit the subscribe button and hit the bell icon for more videos, right? And if you find good information in this, and share this video to your friends who are required, right? And stay tuned to my channel. Thank you.